So running this YouTube channel and working full-time on NAS systems and things like that, I get to do a lot of really fun things, but by far my favorite thing to do that always gets me excited is building petabyte NASs. I've gotten to do a few of them throughout the years, and it is every single time just a blast, because building multi-petabyte and petabyte systems requires an entirely different level of thinking and can give you unbelievably massive performance numbers, and there's so much that can be done there. And in this video, I want to talk through how to build a petabyte NAS. Because if you're a large video production house or other institution that needs just unbelievably massive amounts of data, having it all in one place on a NAS is likely one of the most cost-effective things you can do for storing it, but it comes with a massive amount of planning that has to be done to do it right, because you can very easily build a system that is going to have massive performance problems or can be even unstable and just not easily rebuilt. And so in this video, it's going to be a pretty basic overview on what to look for when building petabyte systems and things like that. Okay, so on this channel, I generally talk about two NAS systems, Synology and TrueNAS. Those are also the two NAS systems I end up deploying the vast majority of the time, because honestly, they complement each other really well. There's almost always a use case for either one of those systems for the vast majority of NAS deployments, and in this case, there is none truer here. So both Synology and TrueNAS can give you a petabyte NAS, but we're going to talk about the fact that they give it to you in a very different way, and one of them is going to be a clear winner, and that is TrueNAS. But I'm also going to talk about a third option here, which is not really a NAS, though it is network attached storage, but it is clustering. So once you start going to these massive systems, it can start to make more and more sense to cluster out, and clustering with object-based storage. So clustering is essentially where not just one server is in charge of all the data, but instead multiple servers with multiple different locations are in charge of the data. And that has a ton of pros and a ton of cons, and we're going to talk about that all in this video. The two I'm going to kind of focus on are Ceph and Mini IO clustering. And they are really designed for two different use cases. Ceph is going to give you by far the closest experience to a NAS, whereas Mini IO is all about S3 object storage, so it's really a different ballgame entirely, but depending on what files you're needing to serve and store, it may make way more sense than anything else on this list. Quick interjection here in the middle of the video. If you didn't hear already, we have found a company that will make custom Hawaiian shirts. We're not making any money off of it or anything like that, but if you're interested in a custom SpaceRex Hawaiian shirt and you want to pre-order before September 23rd, there's a link for that down in the description below. Just one thing to note, these have a very long lead time, so we're expecting to get the order shipped out and delivered to everybody sometime in December, so it is going to be a long lead time, but they look absolutely awesome and we're really excited to get them, and they're to celebrate hitting 100,000 subscribers on YouTube. So check those out in the link description, and back to the video. Okay, so I want to spend the first half of this video talking about the more traditional NAS options, which is TrueNAS and Synology. So I'm going to focus on those to begin with, because really those are your traditional NASs, and they are going to be orders of magnitude easier to work with and manage than either one of the clustered options. And we're going to talk about that in the second part of this video. But to start, for the petabyte level projects, the 1 to 10 petabyte range, and looking for more of a traditional file system where essentially multiple computers can access the files via SMB. If we're focusing on that workflow, you don't even have to really watch the second half of this video, because in almost all cases, it's going to make much more sense to use a traditional NAS option that has a single server that is in charge of all of the data. And we'll talk about why that is in the second part of this video, but it is all about performance, specifically with Windows SMB, and just ease of use. So when we're talking about this range, we're going to start with Synology and TrueNAS. And I should also mention, Synology has plans in place to start clustering out, but we're not going to talk about that in this video. And TrueNAS themselves have also canned their clustering project. TrueNAS Scale, the word scale, was actually because it was meant to be clustered, and from the most recent release, they have axed that. So TrueNAS is no longer going to be a scaled out project. Instead, it is just a single server. And that makes stuff so much easier. All right, so now we're going to start with the Synology option. If you want to go Synology, you really only have one option for these petabyte level projects, and that is this guy right here, the HD6500. This is a massive unit, draws a ton of power, is really loud, but it can store 60 hard drives in the main unit, along with 4 extra 60 drive expansion units for up to 300 hard drives. So this is absolutely, you can throw as many hard drives at this thing as you'd like, and it's just going to keep growing. It has the ability to build a maximum volume size of 1 petabyte. So essentially what you would do is you'd probably put a volume on each of your expansion units, and that's how you would operate this thing. So this is Synology's offerings for the massive deployment systems. And while this unit is a beast, there are some serious limitations when it comes to Synology going past the petabyte level and really past the 500 terabyte level that I need to talk about here. So Synology uses BTRFS for their file system, but they don't use BTRFS RAID. Instead, they use the more traditional NDADM RAID. Then when you're deploying a project that's going to be this large, you don't stick it all in just one massive RAID group. No, you don't set this thing up as like a 60 drive RAID 6 array. Doing that will cause you massive performance issues, and Synology won't even let you do that. Synology actually limits you to 24 hard drives per RAID group. So at most, you could deploy a 24 hard drive RAID 6 array. And in reality, you don't want to do that. For these levels, when you're working with mechanical hard drives, I generally recommend 12 drives across as the maximum. And so then let's say you've got 60 hard drives in there. You will essentially create, and Synology does this all for you, 5 12-wide RAID 6 arrays. So you're essentially chopping up your hard drives into groups of 12 and creating a RAID 6 array on all of them. Then Synology behind the scenes adds them all up into one storage pool using LVM, or Logical Volume Mapper. This allows one file system to access the data across multiple RAID arrays pretty seamlessly. And this is how Synology operates on all their multi-RAID arrays. So while this is a very solid implementation and is unlikely to cause you any issues, it does leave some stuff behind with performance versus something like a ZFS. So the way that this appears to work from my testing and deploying this unit, essentially whenever you're copying files, it is going to send the copies all to one of the RAID groups at once. So you don't get the massive performance as if you have 60 hard drives. Instead, you're basically getting the right performance of 12 hard drives, which is very fast. But when you're trying to dump massive amounts of data to it, can leave some things behind. And so that is one piece that Synology appears to be doing purposefully, is they're trying to get like data all on the same RAID array. And that does slow you down in terms of your massive performance, because you're kind of limited to the performance of one RAID array versus another. But by doing this LVM mapping, you do lose a bit of performance, and Synology is likely doing this to make sure that later on, when you're reading back files, you are ideally hitting one pool at a time, one of those RAID arrays at a time, which will give you better performance, so that way multiple things can be going on, hopefully on different RAID arrays, speeding up your read performance significantly. And this does appear to work. However, there is a significant limitation with Synology in this case, is that they use BTRFS. And while you can absolutely deploy one of these things at a petabyte level, you're never going to get the performance as you will with ZFS. And that brings us on to the real winner of the petabyte level storage systems, and that is TrueNAS. So Synologies are great, especially up to that kind of petabyte level, like right around the 500 terabyte level. They will work well. You do start to see some diminishing returns in terms of performance, just because of BTRFS's limitations and the fact that the file system was never designed to go that big. Once you cross maybe the 500 terabyte level, it becomes very hard to recommend Synology, and instead, I almost always will recommend TrueNAS, unless there's some built-in applications to Synology you cannot live without. TrueNAS works off of ZFS. ZFS was a file system built without limitations, to an absurd degree. The amount of energy required to max out a ZFS volume is enough energy to boil the oceans. When ZFS was being written originally, it was the file system that was not going to have any limitations, and they did that. There's no appreciable maximum size that you can reach with ZFS. It is designed everything to be maxed out. And that is why it is the clear winner once you start talking about multi-petabyte systems, because ZFS can just scale so easily. So Synology deploys NASes with BTRFS. And BTRFS is actually a better option at smaller scales than ZFS is, because ZFS is a bit over-designed for the smaller scale file systems. It requires significantly more RAM, significantly more computational power, and so it's a bit over-designed at the under 50 terabyte level compared to BTRFS, which is a lot lighter weight. Both BTRFS and ZFS both give you copy on write snapshots, so it gives you that great protection and the ability to easily roll back changes and things like that. But ZFS really shines at these massive deployments. And the reason ZFS does this is not only was it designed from the beginning not to have any limitations, it also has by far the most intelligent caching algorithm out there for its file system, and it is fundamentally built in. It is the ARC. It is the adaptive replacement cache. It allows ZFS to do things that other file systems simply cannot. Whereas with BTRFS, if you want to add an SSD cache, you essentially have to add in a layer somewhere else. So Synology uses Facebook's flash cache. And because of that, it's not fundamentally built into the system. ZFS has all of these features in its own code. It is all the exact same stack and all work together. For ZFS, if you want an SSD cache, you deploy what's called a layer 2 ARC. So whereas the ARC is in RAM and is designed to be really fastly accessed, you can essentially extend that out with the layer 2 ARC. And it makes the file system incredibly performant when you're talking about these massive scales. And because of that, because ZFS has all these features built in, it is hands down the best file system to use once you go over 500 terabytes, and is the reason why I very rarely ever recommend clients deploy a Synology NAS over 500 terabytes unless they can split up into multiple volumes, and even then, it's harder to recommend at those larger levels. My OS of choice for ZFS and NASes is actually what I run my video production setups off of, and that is TrueNAS, specifically TrueNAS Scale. So TrueNAS Scale is an open source operating system that is run and managed by a company called IX Systems. I have bought products through IX Systems before for massive TrueNAS deployments, but it is completely open source and you can download and install it on your own hardware, which is currently what is in my back room and is what I edit all my YouTube videos off of. And the beauty of ZFS is it just lets you expand to your heart's content. So whenever you're deploying a massive ZFS array, you actually deploy it in basically the identical way that you do with Synology LVM that I talked about earlier. Except with ZFS, you have far more control over it and you're actually setting everything yourself. And with ZFS, it is all just ZFS components. So with Synology in their multiple volume mapping, they have 3 individual components that all have to work together. MDADM for RAID, LVM for adding the RAIDs together, and BTRFS for the file system. ZFS has all of those pieces under the hood as one unit, and it shows when it comes to performance and just scalability and overall effectiveness. So with ZFS, once you reach your level where you need multiple arrays, you do this with what's called VDEVs, or virtual devices. So your most basic pool with ZFS is just a single Z volume. And there are a few different types. There is RAID Z1, RAID Z2, RAID Z3, or mirror. So RAID Z1 is essentially RAID 5, RAID Z2 is essentially RAID 6, and RAID Z3 is basically RAID 5, RAID 6, except with 3 drives of fault tolerance rather than 2 and 1. There are some key differences between RAID Z1 and RAID 5 that I'm not going to go over here because it's a fundamentally different process of storing data, but for the most part, you can think of them almost identically until you get in the nitty-gritty of small file sizes and some other things like that. So with ZFS, you essentially add up multiple VDEVs or virtual devices And that is where your RAID is held. That's where your storage protection is held, is at the VDEV level. So for this case, this is my TrueNAS server, and this is the SSD pool that I've got. And we've got 2 RAID Z1 arrays of SSDs. So essentially, these 2 RAID Z1 VDEVs are added together to form a larger pool, and this is called SSD. And so that is how you expand out with ZFS. And the really nice thing about this is the way the file system works is, say I need more space. All I have to do is deploy another stack of SSDs to make my 3rd RAID Z1 group and just add it to that pool, and boom, it's immediately expanded on out, and I can start using that space immediately. And this is all built in fundamentally to the file system, and that's why ZFS is so much better once you're doing multi-petabyte loads, because you can just continuously add more and more of these together to get larger and larger arrays, and they're all built together and they all work cohesively to form one massive file system that can be exposed, where you can have a 5 petabyte file system. And that's not a big deal. And I've done it, and it's awesome. Then, because of how intelligent the ARC is, which is essentially your RAM cache that handles both metadata as well as overall file caching, it makes it much, much more efficient in these massive pools, because you can include half a terabyte of RAM, and then all these small operations likely will be pulled just out of RAM without having to go to disks. There's tons of stuff that makes ZFS really efficient and really designed to scale out massively. And that's why once you start talking about over 500 terabytes, I highly recommend deploying a NAS with ZFS if you're looking for a single system, because it's got the ability to just grow infinitely and the hardware is there. TrueNAS has worked great for me for years, and I built both multi-petabyte systems with the open source TrueNAS scale and bought multi-petabyte systems from IX Systems. All right, so that's how the software works. Now let's talk about how the hardware works when you're actually deploying something this large. And it's all using what's called JBODs. JBODs stand for just a bunch of disks, and essentially they are shelves that can store, in a lot of cases now, up to like 90 hard drives in a single disk shelf. They are then generally connected to the primary server with SAS cables, and this right here is what they look like. So it is literally just a bunch of disks, and on the back, it just simply connects to the rest of the system via SAS cables. So all of these come together and are essentially just an entire shelf just designed for disks. It doesn't have any CPU in there or anything like that. All it does is just expose these disks via SAS to a main cable. And the way SAS works is you can actually waterfall SAS. So you can actually connect this JBOD to the one below it, to the one below it, to the one below it, giving you a full stack all off of just technically one SAS cable. In an ideal world though, you're going to want to connect them all to the main unit. And so that is how you build out these massive systems, is you have multiple racks in some cases, all just connected JBOD to JBOD to JBOD with SAS cables, and they all get exposed as just disks to a single head unit. And that gives you flexibility to just continuously expand. The other really nice thing about this is, as you need more data, you just buy more JBODs, slot them in, and add them to the pool, and you've just grown larger and larger. All right, so I'm gonna stop it there. We're not gonna talk about backups in this case because, well, that would make this video very long. But for both backup solutions, I generally would recommend snapshots, because they are able to send over these massive amounts of data in ways that a simple rsync or something similar is going to choke at once you're talking about this much data. So we have talked about our traditional NAS options. Now let's go into the 2 clustering options I want to talk about. And they are pretty easy to tell whether or not they're for you. When I talked about Synology and TrueNAS, both of those options involve a single CPU that is in charge of the entire server. Basically, one head unit is the NAS, and then all computers on the network connect to that. And that has bottlenecks, because you can only build a single server to be so fast. Eventually, you are going to run into a bottleneck somewhere or the other where a single server just cannot handle the amount of traffic. And that's where you start to scale out. So instead of making one more powerful machine, you build 5 mid-powerful machines, and they all add their performance together to give you far more performance. And depending on your deployment, this is either going to give you great performance or terrible performance, and it comes down to what you're looking for. So I want to start with talking about Ceph, because Ceph gives you the closest thing to a standard clustered file system. And 45 Drives is a server company that really champions the clustering mentality. They build these boxes that have 45, 60, I think even now 90 hard drives in them, but they have CPUs in them. And so every single one of their shelves operates as an individual server. And so once you need more than one shelf can manage, you cluster them together to give you faster performance. And this gives you the ability to scale infinitely. Because once you start clustering, you are no longer limited to the throughput and performance of a single server. Plus, you get far better uptime because you can upgrade one server at a time and the other servers will take its place. There's tons of stuff you can do. However, this does come with some problems in terms of performance when it comes to a standard Windows SMB file server. The way SMB works is not something that is really easy to cluster out. And performance-wise, does not give you the massive performance gains that you would see with other file systems. So the biggest reason to see whether or not clustering works for you is what your workflow is. If you're looking for things like iSCSI volumes, NFS shares, or object storage, all of those things are really efficient to cluster. Or if you need more than 10 petabytes of data, that's where even ZFS, you kind of start hitting limitations in terms of just what you should do because of how long it's going to take to restore something if it fails, and other things like that, that clustering solves. So if you're in those 3 categories of needing crazy fast IOPS in terms of NFS or iSCSI, object storage, or massive, and I mean massive, 10 plus petabyte servers, that's where clustering starts to make a lot more sense. Now, you can cluster out an SMB file server. The problem is you just don't get the performance you want if you've got fewer than 100 clients. Once you've got tons and tons of clients, the clustering really helps you speed up, but there always is that overhead. So 45 Drives has switched to Ceph for their clustering, and they make it very easy to set up these things. However, Ceph is significantly more difficult to set up and deploy than a single file server, and there's a lot more stuff you have to look for in that. If you're looking for block data, so there's 2 different types of data. There's block data and there's object storage. Things like virtual machines need to run off of block storage, and just general file systems are all block storage. If you're looking for that, and you're in those 3 categories I talked about, looking at Ceph is going to give you massive flexibility and is probably the right option. There is an additional type of person who needs multiple petabytes of data, and those are people who are storing objects. So an object store is very different than a block level file system. Object store no longer cares about the file system, and instead it just cares about objects. And they are formed in what's called buckets. So S3 was kind of the group that championed this, and it allows you to scale infinitely. File systems always have limitations. Object storage does not. So when you're looking at most websites and you're seeing images come up, more likely than not, those images are not stored as a file system, but rather as objects. More likely than not, they are served off of a bucket. And so buckets store files as objects instead as the more traditional POSIX file system. I'm not going to go into the nitty gritty of this, but because of that, it scales out significantly faster. And both Ceph and Mini.io can create incredibly massive, incredibly fast object storage. So that's my last option to look at is Mini.io for clustering. Mini.io is not something you're going to want to use if you are looking for a file system on top of it, but if you are looking for object storage, specifically Mini.io just acts as an S3 server. Mini.io can let you scale out almost infinitely with multiple servers, multiple backup methods, and tons of options like that, while also giving you huge amounts of performance. And so now finally, this is our fourth option, is for clustering out. If you're looking for object store, Mini.io's got to be there. I actually use it to use client backups just off of a TrueNAS server, funny enough. But for people who are truly looking for these massive deployments and need S3 compatible object store, Mini.io is definitely the one to look at. It is incredibly easy to use and has incredibly massive amounts of scale out. All right, so those are all the different ways you can build these multiple petabyte systems. This is stuff that's super interesting to me, and I know this was a bit of a rant of a video. Let me know how you liked it in the comments below, and if you'd like to see more of these videos. All right, well, that's gonna be it. Have a good one. Bye.